How do you do upgrades? And this is an issue that arises when you have upgraded code that is either rolled out to many servers or where there's an incompatibility between the code being updated and the database schema. So I'll give an example of each of these. If you're using multiple servers, so if you have a large installation, you've got multiple Heroku columns, let's say, then at some point, you're going to have a situation where there's an instant in time where some servers have the new code and some still haven't been updated. So either you shut down your app during that time and you only turn it on again after all the servers are updated, or you have somehow taken steps to make sure that even if the two versions of the code are both running, the app doesn't break. And that can be a little bit tricky. Or a similar scenario, even if you only have one server, you're about to roll out a new version of the code, but the new version of the code also includes a change to the database schema. So and in particular, it's a case where it's not backwards compatible. So if you were to roll out the schema first, it would break the app because the current code can't deal with the new schema. If you were to roll out the app code first, it would break because it needs the new schema in place. So again, you have this awful choice of, well, you could either shut down the entire app from the user's point of view, do all of the upgrades, and then bring it back up, or is there some more graceful way to handle this if you can't afford to have your app be down? And by the way, a schema migration that actually includes modifying data could take minutes. So it might be a significant amount of downtime from the point of view of the user. And if you're a site that has users in different time zones and stuff, you can't assume that, oh, I'll just do it at 3 in the morning when nobody's up. Somebody is always up. So what are the two approaches here? The naive approach, and by the way, if you can do the naive approach, you should do it. If you know that your users are never online between 2 and 4 in the morning, that is a great time to do this. You take the service offline, you do whatever has to be done, including migrations that won't work with the old code schema. You deploy the new code, you deploy the new migration, you make sure all the servers are up to date, and then the app comes back up. So the users don't have access to the app during this intermediate state when it hasn't been fully updated yet. The only downside to doing this is that there is downtime. And depending on the app, the downtime could be a matter of less than a minute, in which case maybe it's not a problem. Or it could be minutes or worse, in which case it's a problem. What does this look like for a sort of a typical Rails app? Here's a hypothetical example where the change that I'm making is previously I had just a name field, and now instead I want to have first name and last name in 2 separate fields in the database. That means that every place in the app that manipulates names is going to have to know about this change, and the old version of the app won't work with the new schema and vice versa. So if I have the luxury of bringing down my service, I can just shut down the service, and then I can apply this migration, which says for every single moviegoer, and there may be millions of them, in the database, update create the 2 new columns, first name and last name, and then for every single moviegoer, populate the columns from whatever the existing name field is. So the logic is pretty simple, but if there's a lot of users, that could take a really long time. And you may or may not have the luxury of bringing down the application during that time. Oh, and of course, by the way, once that's all done, I can remove the old name column because that isn't needed anymore, because the new code is only going to look at first name and last name. If you can afford to do it this way, you should do it this way. This is simple. You can back up your database immediately beforehand so that if something goes super awry, you can restore your database. You can do all of this under the covers while the app is not available to the users, and you can do it at 3 in the morning when only CS169 students are awake. In fact, you could even be fancy, and you could wrap that entire migration in a transaction so that if anything goes wrong in the middle of the transaction, the whole thing is blown away as if nothing had ever happened. Of course, that takes hella memory and hella more time, but if the app is already going to be down for a while anyway, again, this is the simplest brute force thing that can work, and I am a big fan of using simple brute force if that will suffice. But what if brute force does not suffice? If you don't have the option of taking your app down and you need to do this in a sort of transitional way, then you can use this really cool thing called a feature flag. And here's the general approach. I'll sort of walk through the code, but you kind of break it into steps where in the first set of steps, you do non-destructive migrations. What does that mean? Maybe you're adding new columns to the database, maybe you're adding tables, but you are not destroying or changing any existing data or any existing schema to make sure that you don't cause any problems with the existing version of the code. Then you deploy your new code protected by a feature flag, which I'm about to show you what that is. But TLDR is that a feature flag is a condition in the code that basically says, if we're in a situation where we're dealing with records that are in the new schema, do this over here. But if the situation is records in the old schema, do that over there. And by the way, once you've done that over there, migrate those records to look like the new schema. It's very cool. I'll show you in a minute. Once the code is deployed, turn on the feature flag. That will start activating the code path that allows the records to be lazily migrated. Once all of the records have been migrated, you can deploy new code that lacks the feature flag. And finally, you can delete the old schema parts that you don't need anymore. So again, let me show you a concrete example which should make it more clear. And this is the same scenario, by the way. The scenario is that we want to change it from being first name, or from just a single name field to first name and last name. But this time we're going to do it without any downtime in the application. Okay? So here's what we're going to do. The first part is the top like half dozen lines. We're creating a migration that adds the new columns for first and last name. It does not change or modify in any way the existing data that has a name column with the entire name in it. So it's just adding stuff. It's not destructive. And you can run that migration. That's quick to run. You don't need any downtime for that. Then we're going to deploy a new version of the code that does the following thing. You'll notice we've also added a column called moviegoers, which is Boolean, migrated in the moviegoers table, which is Boolean valued. And basically what we're going to do is for every row in the moviegoers table, we're going to keep track of whether that row has or has not been migrated to the new schema where first and last name are separate. So here in our new version of the app, we're going to create two different basically scopes to condition our active record queries. We're going to say we're using the old schema if the migrated column is set to false. We're using the new schema if it's set to true. And we're going to have basically a method that says when the find matching names method, which is like one of the places that the code has to change in order to accommodate the schema, there's basically going to be two versions of that method now. So in the old code, basically if we have a feature flag that once we flip it on, will basically say how do you find somebody by name if you don't know which schema they're in? Well, it's moviegoers that are using the new schema. Then the condition is the last name or the first name match the string. Moviegoers that are using the old schema, it's basically just a single match on a single field. So if the feature flag is turned on, meaning it is now, you may now assume that you're dealing with either version of the schema, the logic of this old method has now been changed so that on a row-by-row basis, it'll do the right thing. Basically, what used to be one query has been turned into two queries. Otherwise, if the feature flag is not turned on, then this is the logic that would have been in the old method, right? So basically, the old find matching names method was just this one line. We've wrapped that line in an else. So what's the net effect of doing something like this? The find matching names method is basically going to allow the code to work correctly under either schema. And in particular, some records in the table will have been migrated, and their migrated flag will be set to true. In that case, they'll be included as part of this first clause. Some records in the table will still be using the old schema, in which case the migrate flag is set to false. They will be caught by this clause of the query, and the two queries are just union together. Okay, so see what I did there? I basically created a version of the logic that is prepared to deal with records from either schema and combine them in the right way. The other cool trick that we have to do is anytime one of these records is modified, so if a moviegoer goes in and modifies their profile or anything happens that could change the record, that is a great opportunity to take a legacy record and move it to the new schema. So here's a function that does just that. Basically, as long as the unmigrated legacy user has a name that looks like it can be split into a first name part and a last name part, it will set those records in the database row for that customer. It will set the migrated flag to true. And where am I calling this? I'm using the before save active record hook. I could have put it somewhere else, but it's an interesting use of an example of the lifecycle hooks. So basically this says anytime any moviegoer is about to be saved, before finalizing the save, do these things. So this has the effect of one at a time, whenever that user happens to be saved, it will update them. It'll set their migrated flag to true. So over time, more and more of the records will be in this migrated true new schema. Fewer and fewer of them will be in the old schema. Maybe there are some users who never log in, and at some point I just say, OK, I'm going to mass migrate all those users using some sort of a background job. So the only thing left to do is somehow this new name schema feature flag has to be flipped on. Just deploying this code doesn't do anything. But once I deploy the code is running. I'm confident everything works right, because this is the only method that's being called. Right? I haven't turned the feature flag on. Now I do whatever is necessary to turn on the feature flag. And all of a sudden, now the code can go down either path. So the trickle of migrations from one to the other begins. And then once I've either migrated all the users over or decided that, for the users that I haven't had a chance to migrate over, they're inactive. So I'm just going to start migrating them over anyway. And I'll run a background job to trickle that. At some point, it'll be the case that none of the users have the old schema anymore. At that point, I can do two things. First of all, I can deploy a new version of the code where this legacy stuff is entirely gone and the references to the feature flag are absent. Second, I can then run a migration that deletes the old name column, because now I know it's not really being used anymore. It is no longer referenced anywhere in the code, so it's safe to delete. So we'll finish up this example, and I'll show you another cool, tricky example on Tuesday. But this is basically a good template. You do the non-destructive parts. You put in code that is conditioned on a feature flag that can deal with either the old or the new version. Once that code is sort of running and humming along, you turn on the feature flag and you let the code start doing its thing. And once the migration of the data is done, you can deploy code that leaves out the feature flag, run a new migration that gets rid of the old stuff you no longer need. And at no time did you have to take your app offline to do that. You can keep your app running the whole time.